Week 3. The AI Revolution and Global Power Competition. A. Introduction, AI and the Transformation of Global Power. In the 21st century, artificial intelligence, AI has emerged as a central driver of global power transformation. Similar to previous technological revolutions, such as the Industrial Revolution, the nuclear age, and the digital revolution, AI is reshaping the structure of international politics and redefining the nature of power itself. AI is no longer confined to a specific sector, rather, it operates across economic, military, political, and social domains. As such, it has become a critical determinant of national capability and strategic autonomy. States that successfully develop and integrate AI into their national systems are likely to gain a significant advantage in global competition. This lecture examines three key dimensions of the AI revolution: AI as strategic infrastructure, B. US-China AI competition, and C. Semiconductor geopolitics involving Taiwan, Korea, and the EU Chips Act. B. AI as strategic infrastructure. 1. The infrastructure nature of AI. AI should be understood as a form of general-purpose infrastructure, rather than a standalone technology. Like electricity, railroads, or the internet, AI has a wide range of applications that extend across all sectors of society. Its infrastructural characteristics include: universality. AI can be applied to virtually all industries and policy areas. Scalability. AI systems improve as more data is accumulated. Network effects. More users generate more data, which enhances performance and attracts even more users. Civil-military integration. The boundary between civilian and military applications is increasingly blurred. These characteristics elevate AI from a technological innovation to a matter of national security and strategic competition. 2. Core components: data, algorithms, and compute. The effectiveness of AI systems depends on three essential components. On data. Data serves as the fuel of AI. Countries with access to large-scale, high-quality data have a competitive advantage. Democratic systems often face constraints due to privacy regulations. Authoritarian systems may have fewer restrictions, allowing extensive data collection. Thus, political systems themselves can influence AI competitiveness. 2. Algorithms. Algorithms function as the brain of AI. Advances in machine learning and generative AI have significantly increased the importance of algorithmic innovation. The United States leads in cutting-edge research and innovation through private firms. China emphasizes state-led development combined with corporate collaboration. 3. Computing power. Compute represents the engine of AI, largely dependent on advanced semiconductors and high-performance computing infrastructure. GPUs, AI chips, and data centers are critical. Access to cutting-edge chips determines the upper limits of AI capability. This leads directly to the geopolitics of semiconductors. 3. AI and military transformation. AI is transforming military affairs in fundamental ways. Autonomous weapon systems, enhanced intelligence, surveillance, and reconnaissance (ISR), cyber warfare and information operations, automated command and control systems. These developments accelerate the speed of warfare, reduce human intervention, and increase asymmetrical capabilities. Consequently, AI is reshaping not only military power, but also the nature of conflict itself. C. US-China AI competition. 1. AI as a core arena of great power rivalry. The competition between the United States and China over AI is a central feature of contemporary international relations. It is not merely a technological race, but a broader contest for global leadership and influence. The United States seeks to maintain a liberal international order. China aims to establish an alternative model of governance and technological leadership. AI serves as a critical game-changer in this rivalry. 2. The United States strategy. The U.S. approach to AI development is characterized by: 1. Private sector leadership. Innovation is driven by major technology companies such as Google, Microsoft, and OpenAI, supported by a dynamic venture capital ecosystem. 2. Alliance-based technology networks. The U.S. collaborates with allies including NATO members, the EU, Japan, and South Korea to build a technological bloc. 3. Strategic technology controls. The U.S. imposes export controls on advanced semiconductors and restricts technology transfers to China. This strategy can be summarized as open innovation, combined with selective containment. 3. The China strategy. China follows a state-led model of AI development, one government-led initiatives. Policies such as the Next Generation AI Development Plan guide national investment and coordination. 2. Data advantage. China leverages its large population and digital platforms to accumulate vast amounts of data. 3. Technological self-reliance. China seeks to reduce dependence on foreign technologies, particularly in semiconductors. This approach reflects a state-centric integrated model. 4. Key areas of competition. The U.S.-China rivalry focuses on several critical domains: generative AI, military AI applications, semiconductor and AI chip production. Semiconductors in particular represent a strategic bottleneck in the competition. 5. Toward a digital Cold War. The intensifying rivalry is leading to technological bloc formation, supply chain decoupling, competition over global standards. These trends resemble a digital Cold War, characterized by systemic competition between two technological ecosystems. D. Semiconductor geopolitics. 1. Strategic importance of semiconductors. Semiconductors are the backbone of the AI revolution. They are essential for computing, communication, defense, and industrial production. Thus, semiconductors have become a strategic asset, central to national security and global power. 2. Taiwan, the core of the global supply chain. Taiwan plays a pivotal role in the global semiconductor industry. Home to TSMC, the world's leading advanced chip manufacturer. Dominance in cutting-edge fabrication processes 5 nano and below. Taiwan represents a geopolitical flashpoint in U.S.-China relations, a single point of failure in global supply chains. Stability in the Taiwan Strait is therefore crucial for global economic stability. 3. South Korea, a key technological power. South Korea is a global leader in memory semiconductors. Major firms Samsung Electronics and SK Hynix. Strong capabilities in DRAM and NAND technologies. South Korea occupies a strategic position, a critical partner in U.S.-led supply chains, a balancing actor between the U.S. and China. Its dual role requires careful strategic and diplomatic management. 4. The EU Chips Act. Pursuing strategic autonomy. The European Union has launched the EU Chips Act to strengthen its semiconductor capabilities. Key objectives include increasing domestic semiconductor production, securing supply chain resilience, enhancing technological sovereignty. This initiative reflects a broader shift toward industrial policy and strategic autonomy in Europe. 5. Supply chain restructuring. Semiconductor geopolitics is driving major changes in global supply chains. Friendshoring, relocating production to allied countries. Reshoring, bringing production back to domestic territory. Decoupling, separating U.S. and Chinese technological ecosystems. These trends signal a move away from globalization toward a system centered on economic security. Conclusion. AI, power, and the future international order. The AI revolution is fundamentally reshaping global power structures. AI is not merely a technological advancement, but a core component of national power. Key conclusions are as follows. AI functions as strategic infrastructure that determines national competitiveness. The U.S.-China rivalry is increasingly centered on AI and related technologies. Semiconductors are the critical resource underpinning AI development. Global supply chains are being reorganized along geopolitical lines. As a result, the international system is undergoing profound transformation, from unipolarity to multipolarity, from free trade to economic security, from global cooperation to technological bloc competition. In the AI era, the equation technology equals power has become more relevant than ever. The central question for the future is, who will control AI and what kind of global order will it produce? The answer to this question will define the trajectory of international relations in the 21st century.